In this video, I will be explaining how to solve a problems of related rates from an equation that shows the relation between two or more variables of interest, let's say x, y, r, or whatever other variables. We can obtain the relation between the rates of change, so between dy dt, dx dt, dr dt, etc. So we can find the relation. The related rates problem is a problem in which you are going to find the relation between this rate of change. Remember that the derivatives are the rate of change. So you are going to find a relation between their derivative respect to an independent variable. Usually this independent variable is the time. So you are going to follow several steps. The first step is differentiate both sides of the equation respect to the time, so respect to the independent variable. Take into account to use the chain rule for a variable other than time. If you have in the equation a variable that is not the time, use the chain rule. So you need to have an equation, but in many problems they don't give you the equation, but you need to find an equation in the mathematics that you know that make you see a relation between the variables. After you have this, as a first step, get the derivative both sides of the equation. Remember, use the chain rule when you get the derivative of anything that is not the time. For example, if you get a function u of x, so you need to get the derivative of u respect to x, but then you need to multiply by the derivative of x respect to the time. So you need to use the chain rule in this case. And as a second step, if your goal is to obtain the value of a specific rate of change, and that is always the case, say dx dt, your goal is to find the x dt, solve the equation for this rate. Usually there is a third step. Usually you need to find this derivative in a specific point of time. So in that case, as a third step, it's like you take a picture of the problem. You see what happened at that time, what are the variables of each of the variables, and each of the rate of change involved in the problem at that point of time. Usually this is given in the problem, or you can find it in the problem. So let's see an example. Imagine that we have this as a problem. The relation between revenue generated and the number of full-time employees for a particular company can be approximated by this equation: 15M plus 32R equal 3,000, where R is revenue in millions of dollars and M is the number of employees. In 2015, the rate of change of revenue with respect to the time was 750 million per year. Find the rate of change of the number of employees with respect to time that year. So this is an example of related rates. We need to find the rate of change, but we have an equation at the beginning that can help me to see how is the relation between the variables. This equation is given in this problem. Sometimes there are some problems in which with the mathematics you need to find the relation. So this is a problem in which they give me the relation between the variable. They tell me that the number of full-time employees in these companies is approximated this equation, where this R is the revenue in millions of dollars. So there is a relation between the number of employees and the revenue of the company. If we have this relation, we can get the relation between the rates. Just get the derivative both sides. Okay, so we have the equation 15M plus 32R equal 3,000. Well, when I get the derivative, we use implicit differentiation, so we get the derivative of each of the term. So the derivative of 15m, this is a variable different than time, so it will be 15 dn dt. So when I get the derivative of this, so it will be 15, the constant 15 multiplied by the derivative of the function. So the derivative of the function respect to t. So this 15n is this u of x. The 15n is a function respect to the variable n. In this case, I say respect to the variable x. Could be any other variable. This 15n is like u of n. So the derivative of this and multiplied by the n dt. In this case, will be 15 dn dt. Here again we have the same. Yes, we don't have t here. It will be 32 plus 32. The derivative of the variable to the power 1 is just 1 dr dt. So it will be plus 32 times 1 dr dt. So if this were r squared, for example, it will be 32, and the derivative of r squared will be 2r dr dt. So we are going to use the chain rule anytime that we have something that is not the time. And this will be equal at the other side, the derivative of 3000. The derivative of a constant is 0, so it will be equal 0. And now, this is the first step. Differentiate both sides of the equation with respect to the time. So this is 15 dn dt, this is 32 dr dt, and this is equal 0. And now, second step is, if your goal is to obtain the value of a specific rate of change, in this case, find the rate of change of the number of employees. So we want to find the NDT, the rate of change of the number of employees. So solve the equation for this rate. So it will be this 32 dr dt can be written negative to the other side. So the NDT will be minus 32 dr dt divided by 15. So that gives me the NDT. This is part of the solution. Usually a problem asks me to compute the desired rate of change at a specific time. If that is the case, as a step 3, substitute the value of that variable and rate of change at that time. So that's the moment when you take the picture. You take picture in 2015. The question was what happened in 2015. And in 2015, this DRDT was 750 million per year. That was given here. So we take into account that in this case, the problem says that in 2015, the RDT was 750. So I'm going to solve the problem at this point of time when t equal 2015. At that point of time, the RDT was 750. So I make a substitution of 750 here, and then the NDT at that point of time was minus 32 over 15 multiplied by 750. If I work this using my calculator, I notice that the NDT at that time was 1600. We notice that the value is negative. Because this value is negative, I notice that the number of employees is decreasing. So I'm gonna say that in 2015, at the moment of the problem, the number of employees was decreasing in a rate of 1600 employees per year. Because the 750 was 750 millions per year, I noticed that the unit of times is year. So I can say then that the 1600 is employees per year. Okay, with that, I finish the explanation of how to solve a problem of related rates. I hope you found it useful. Thank you.